Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, easy level question, power of 2. So basically this is a easy level question, but if you get that how we are required to do this question, how to build up intuition about this question, although when you will read this question, it is pretty simple. You can use brute force and it will work because the constraints are like that. But still, the way here follow up, which is written that could you solve it without loops or recursion, basically every learnings come from that point. And in that, you need to go ahead and write whatever pattern comes into picture with all the things which are there. So let's get started. So here the question says that given an integer n, return true if it is a power of 2, otherwise return false. So it's pretty simple thing that if a particular number is power of 2, then you need to return true, and if it is not, you need to return false. Now next thing is an integer n is a power of 2 if there exists an integer x such that n equals to 2 raised to power any power it could be. That's why they have written as x. So here n is given as 1 and we know that 2 raised to power 0 equals to 1. Then here n is equals to 16 and we know that 2 raised to power 4 is 16. Then n equals to 3 and we know that there is no power of 2 which is equals to 3. So now let's first do this particular question with the knife solution. Then we'll go ahead with building up the intuition behind that how we can come up with the optimized version of the same. So see, here we already know that when we need to see that if a particular number is power of 2 or not. First thing is that if it is power of 2, so better than so if a particular number is power of 2, that simply means it would be a even number, right? And other thing which is there is that for all these power of 2 which is there and as per the constraint, it is from minus 2 raised to power 31 till 2 raised to power 31 minus 1, right? So here in all that context there will be negative numbers as well, but and even in the question as well it is not given that we need to figure out for negative number or not. But anyhow, the question says we just need to figure out the power of 2. So surely they will be even numbers, that is for sure, but there is a twist in that also. See, 6 is a even number, but it is not power of 2. We all know that 2 raised to power, if I represent it in, okay, let me do by 2 raised to power things only. If we do 2 raised to power 2 plus, we are required to basically add 2 raised to power 2 is 4, and then we are required to add 2, then we will be getting this 6. So all even numbers will not be the power of 2. That is also one thing. And other thing is this also, that all odd numbers are not power of 2, but there is one odd number which is power 2 and that is 1. So these three things are there. Now comes the part that the knife solution how we can write with this observation. So the first thing which is there is that first thing that all the odd numbers we need to exclude, but there is one odd number which we need to include and that is 1. So if n equals to 1, then we would be required to return true because we know that 2 raised to power 0 is equals to 1, so that is power of 2. Now next comes the part that here we will be including all the positive numbers, although here the negative numbers are also given, so that's why we will be just including the positive numbers. So here only we will write the check that if n is greater than okay, let us write it that if n is less than or equals to 0, then we will be returning as false. Why we better we just fail safe at that point only if it is equals to 0 or if it is less than 0. That simply means that we already know that 0 is not at all a power of 2, right? So because of that thing we will be excluding that number as well. Now comes the next part. That how we will be going ahead with our loop. So think. So now the main thing would be that we will be checking for the even numbers for sure, but we will be also checking if there comes any odd number, then we need to like simply basically return false at that point. So this thing we can do in loop as well, and we can do by recursive solution as well. And how that we will be doing this, the thing is like first thing we will check that it is even number or not. So we'll at that point only we'll check by doing modulo by 2. That simply means if it is equals to 0, that nothing remains, that simply means it is an even number. So at that point, but the thing is not every even number is power of 2 the way 6 is not, right? So that's why we are actually required to do a recursive call to our function itself. And how that thing we will be doing is here itself we will be actually dividing this number by 2. When we will be dividing that by 2, so whatever comes as the answer, that will be our new n, right? And if that new n is not an even number, right, so it won't come to that point, and then it will be basically going to the else part where we know that yeah, we need to return false. So that is how the things would be for this portion. Even if we don't use this, still it's fine. Now the thing is that here at this point we will be just dividing by 2. Means here if we are having 4, then we'll divide by 2 and we will be passing 2 to this particular, and then it will check it is not this, it is not this, but it is this. That's why it will again come to this. Then at this point 2 divide by 2 which one be equals to 1, and it will return true, because when one will go here, it will come to this point and then it will check, then it will straightforward return true. But the part for say 6, so here first it will divide by 2, so it will become 3, and then that 3 is being passed here, so it won't be this, it won't be this, and even it won't be this. So that's why it will go to this particular point and it will return false. And when this particular return false, it return false to its parent caller, that is this person. And at this point itself, basically when stack unwinds, at that point it will simply return the result as false. So that is what will happen in our this solution. And let's basically submit this for our test cases which are there. So all test cases are passed. And another thing, if we say about the time complexity and space complexity, the space complexity which would be there, that will, if we ignore that recursive stack space complexity, then the space complexity is order of 1. But if we consider that, then yeah, surely it will be basically as per the number of divides which are there and how much it builds up. And we know that it can go 2 raised to power 31, which is there, means these numbers could be till this point. So basically in that context, it will come to that point that these, basically it comes under the, what we say, as per the constraint, it will never show the what we say, that it will never show us that it is out of bound, not out of bound. Basically it will be accepted for the test cases as which are in this particular constraint. I'm not getting that exact word, but yeah. So the thing is, like, it will be an accepted answer as per the constraints which are there, and even the stack will unwind till that point. Now the thing is about the time complexity. So that will be again as per the n only, means number of divides would be there as per n. So basically in this context, the time complexity would be again order of n which is there, and space complexity will be also order of n if the stacks space is considered, that recursive stack which is there, its space is considered then. So basically, if we submit this particular solution, then it will get, let us see, it will get submitted. Yeah, and it beats 100%. It is like one of the great solution. But the thing is that as per the follow up, they have mentioned that could you solve it without loops or recursion? So for that thing, we need to observe one pattern which is being followed in this question, and that we need to do. So that's the thing here. And if we follow that, then we will be able to figure out that, yeah, how more easily we can do this particular question. Means here we are having time complexity order of n and space complexity order of n. That could be even reduced to order of 1. So that is the thing. So now for that, let us just reset this and go ahead. So now the whole thing is, if you see these numbers which are there, which are power of 2, let us start from scratch. First one is this one. So if we consider till 5 zeros, let us say, then for the 2, it is something like 0 0 1 0. If we say for 4, then it is something like 0 0 1 0, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. If we say for 8, it is something like 0 1 0 0. For 16, it becomes like, if you can see here, there is one common pattern in all of these. If you observe this, it's like you can see in each and every 2 raised to power, we have only one bit set in all of this. That is one observation of the same. So if we convert this question from just a naive one of just dividing or something to bitwise, then we can clearly see that all the power of 2 which are there, in that we have only one bit set. So what we can do is we can convert these numbers to the uh, to basically a bit set. In that we will be having that what all bits are set, and in that we will be able to figure out that only one bit is set, and if that is the case, like, then we can return that. So that is what we can do in this particular solution. That is one of the, basically, one of the solution. We have actually one more solution, and that I'll tell you after this one. So here, see, what we can do is we can basically convert that to a bit set, and we will be taking 32 because as per the constraint we have 2 raised to power 31, so 32 size is fine for us. And then let's name it as bits, and we are having this n, basically our n we are required to convert that to bit set. So now if you will print this, it will show you all the bits which are there. So let me show you how to print that even. So we'll just do this, and this bits which are there, bits dot, we'll do that in the form of string which are there. And basically we have this function, and let us just use endl itself, and for time being we'll just return 0 so that it don't throw any error. Yeah, we'll run that. I'm just showing the output. This is not the final one. See, so you can clearly see this one is being converted to a 32 bit set, a 32 bits number where this bit is set, and that we can see. Then for this case, 16, the thing which I had shown here, same. Basically, what they do is they will convert a number into its bits equivalent. And for this case, here also, right? So now we'll comment this, and now comes the part what actually we need to do. So as per our observation, we can see all the power of 2 have only one bit set. So what we will do is, first thing is we'll check that it is a positive number. So first thing is we need to return only and only if it is greater than 0, and this is not bitwise AND. So we need to have that double and we will check this bits which is there, right? Bits dot count, that should be equals to 1. That means that only one bit is set. Here we can see, right, only one bit is set in all of these, and here also we checked that only one bit is set. So when we will be returning this solution, now it won't throw like that. So yeah, it got accepted. And if I submit this, that will also surely get accepted. Hmm. That also got accepted. Now, this was one thing which was using a data structure bit set. But what if we do interviews say us that I don't require any data structure to be used, although the time complexity and space complexity which is here, now it has been already reduced to order of 1. That is for sure. Both are like order of 1 only. Fine. Why space complexity is order of 1? Because 32, that is not that much space. So it is like, it is a constant space basically. So it is equivalent to 1 only. And time complexity, we can see that it just gets converted. Actually, I'm not sure that how much, because it is converting, so what all operation it will take behind for the same. Yeah, actually need to read about this. Fine, but that is for sure that it is not taking time complexity the way. No, let us confirm only. It is saying something else. What will be? Mm, Advice operation. These are just saying about long. We require for. Okay, fine. I'll I'll search and I'll post in the comments. But as far as I know, it should be like order of 1 only rather than order of n. So basically, this thing which is happening, so here this bit set which is a constructor basically. So what it does behind the scene is it will take your number and it will, the way we store our integers, it takes like 4 byte, right? So it basically stores that number itself, basically it copies, not that exact number, means not exact memory location which was there, it doesn't affect the original number, but it just copies that number which is there to some other place, which will be also 4 bytes in size only, because we know this is a 32 bit, so which actually stores just 4 bytes of our memory. So that's why like it is not that much heavy operation, so that's why the time complexity here becomes order of 1. When we are doing much heavier operations, then yeah, that we consider, but it is not that much heavy operation, just a constant time operation. So that's why here the time complexity is order of 1, and the space complexity is also order of 1, as I told that it is just storing 32, which is a constant, and almost it becomes order of 1. So that's why the solution is order of 1 and both time complexity and space complexity. But the thing is, like, what I feel is still it is using some space now. Like, still it is using some other thing to store into it, it copies from some other. We can have some more optimized solution over this. And for that purpose, we need to observe one more pattern in the same. So I'll just clean up this part only. We'll observe the other pattern which is there is, see, although our bits, we can see it is having just one bit asset, but if we consider the numbers which are just behind them, so 2 which was there, its number behind that is 1, right? So 1 is set here and 1 is set here, fine. Now if we consider 3 number which is just behind our 4, if we consider that number, so how the bits would be for that? So it will be something like this: 0 0 0, not the 0, it will be yeah, exactly 0, and these two bits will be set. Now if we consider a number just behind 8, that is 7, then here if you see, the bit set would be something like 0 0, and then all will be 1 here. It will be something like that. If we consider for 16, the thing would be 15 which is there, so it will be something like this will be 0 but all others are 1. And this is a common pattern for all the numbers which are power of 2. So here if you see, what we can do is, if we basically do and of the present number and a number which is just behind that, basically if we do and, like we are having n, and if, and we do and of n minus 1, right? So now if we take n as something like this and n minus 1, we know how we do bitwise negation. The bitwise negation works like this: if we are having 0, then anyhow we will be taking a carry from the same, means the previous one which is there, and that previous one take carry from this. So that all together will become something like this: 0 0, and all others will be 1, means they will be turned as 1. If you recall your bitwise subtraction, I did it in, I guess, second semester or maybe second year. So yeah, it's long back. Fine. But the common thing is, like when we do negation of this, so basically this will also turn 0, but all others 0 which were there, that will become 1. So that is how these will be. So now comes the part for the and. So if you do and of the same, 0 0 1 0 0, and this one 0 0 0 1 1. So here if you see, when we do and simply means 1 0 is 0, 0 1 is 0, but 1 1 becomes 1, right? So here when we do and, so it will be all zeros, because here for 0 0, anyhow that will be 0, 1 0 becomes 0, 0 1 becomes 0, 0 1 becomes 0, so that's why. So this is that observation. That's the word which I was finding. This is that observation which gives us our final optimized solution, completely order of 1 in time complexity and space complexity, no copying, nothing, means no copying of those numbers from one place to other and something like that. Simplest, but one line, that is, we need to have a number should be positive, that is for sure, because as per the constraint we have numbers which are negative. And this and is basically a simple AND, not that bitwise AND. Now comes the part for the bitwise AND. N and n minus 1, which we were doing here. N and n minus 1, in we need to do AND of both, and that should be equals to 0. Then only we can say that it is power of 2. So now let us run this solution. ओके कुछ तो गड़बड़ है. ओके, ब्रैकेट्स कहीं पंगा है. What we'll do is we'll just do, let us keep this bracket something like this. Fine. Nice. Good compilation errors. Sorry, syntax errors actually. So this got accepted. What else I was about to tell? Yeah, anyhow, the time complexity is order of 1. Now this I can say truly order of 1. Nothing copying to any other location, nothing like that. So it's truly order of 1 in space complexity and time complexity also, because what it is doing, it is just doing those bitwise operation and giving us the conclusion that after doing and of those, we are getting this. So yeah, I was about to tell something, I just forgot, but fine. For this part, this is all. So basically, this question which is there, this is actually used in a lot of hard questions. But what you can do, and now you also know the derivation of this particular. Yeah, I now the thing is, when I was doing this question, although I observed this pattern for sure, and that's why we got to this particular solution. But one more thing which came to my mind was that what if we do n plus 1 and do the and? For that also I observed, if you see here, these three number only if you observe. So now if we want to check 2 and do its and with this 3, here we will be getting that, okay, here we will be getting 1. Now if we observe 4 with 5, here what I'm trying to do is check for the next ones. So the 5 is something like it will require 4 0 0 1 0 1. 5 will be like this. Now the other number is this 8, and its next one which is there, it is something like 0. It will require 8 as well, 0 0 1. So here if we do that and part, so it would be something like if we do plus, and it should be, because when we do and of that, all of this will be 1 1. Yeah, that won't actually give us answer, not even this and part. Okay, let us just try what actually it comes out to be. Anyhow, that will be wrong only. Hmm. But the thing is, what actually after this I observed was that in all of these, if we want to, that becomes a separate question itself. That if we want to check that it is having this last bit being set, that is for sure. Um, when we do and of these two bits will be always set in this case. That is for sure. The number itself, and if we are doing and with the next number, then the bit where the one was set, yeah, that is 2 raised to power 0. Both things would be there. But that is a completely separate question which we don't need to like check into the same. It becomes of the form like something we can call as 2 raised to power k minus 1. So, but not the power of 2. So if there are some question like that, then in that context we can use that formula. Means here this would be there, means plus would be there, and it would be equals to 0. So that will be check something like that. So that is the thing in that context. But anyhow, the main context of this particular question is that it should be for power of 2. Not all evens are power of 2, and not all odds are power of 2. We need to have this thing in our mind, and the observation of the same is like the previous number and then present number, its and should be equals to 0. And this trick itself, just this one line thing, we can use in a lot of hard level questions. because anyhow hard level question, some of the hard level questions are basically combination of a lot of easy questions. So that is one thing. So that's why this question is important actually. So now, anyhow, uh, let us run it again. Anyhow, this is fine. So this is all done for the day. I hope you learned these three methods and it was a good learning session for you all. So this was all. Thank you.